Hey everybody, welcome back. This is Jonathan Gardner. We're continuing the lecture on binary numbers.
Let's talk about how computers organize their memory. Okay, this will be very quick. So the computer, inside of the silicon, they have little areas with some circuitry printed on there. And each one of these can either be charged or uncharged. Okay, and depending on the exact technology, a charge could represent 1 or 0. So basically each of these could be bits, and they can store 1 or 0, and this is typically organized into 8 bits, which we call 1 byte. Okay, and so if you have 64, let's say you have a 16 gigabyte memory computer, so you have a decent desktop, right? It's not the best, but it's pretty good. So that's going to be 16 billion, more or less, 8 bits. Okay, so the actual number is going to be much larger. It's 8 times 16 billion. That's the number of bits you get. Okay. Then we have the idea that everything must fit somehow into this binary format. Every number, every word, every sound, every video, every color must fit into this little window of bits. Okay. And some computers, they organize things by 16 bits. So you get 16 bits in a row is kind of 1 unit, or you can get 32 or 64 obviously as well. Okay, now it's up to us programmers to organize memory, these little bits, and turn them into text, or turn them into sounds or videos or colors or whatever it is that we're supposed to do with that. That's our job. So we have to understand how things are stored and how things are retrieved and how they're used. Okay, so how does Python store integers? I think it's rather obvious. Positive integers just use bits. So it's like if you'd have this one, this one, this one, this one, this one, this would be the bit 6, right? That would be the value 6. So we just organize a region of memory, set the bits according to binary, and then there you go. There's your positive integer. Negative integers use something called 2's complement. What 2's complement means is you flip the bits and then you add 1. Okay, so if we wanted to represent negative 6, what we'll do is we'll take 6, we'll flip the bits, and then we'll add 1. Okay, and so this is negative 6. Okay, now you might be saying, well, it's also 10, right? Well, it depends on how big the slot is assigned. So generally, if we've assigned 4 bits for a number, then this first bit is going to represent the sign. Okay, so if that bit is set, this is the negative number. If it's a 0, then it's a positive number. Okay, and if you have a negative number, you want to get the positive. Let's do this. So you have, this is negative 6. Let's flip the bits and add 1. And that's 6. So we know that this number here is negative 6 because when we flip it, it goes back to 6. Okay, that's how you represent negative numbers in 2's complement. Little side note, if you say like, hey, 0b1100, Python is going to give you 12. It's not going to give you negative whatever. Okay, if you want the negative number, then what you can do is you can do something like this. And you say ampersand, which we'll talk about the ampersand operator in a minute. And then like, let's say negative 12. And that should give you the bit pattern, the number that represents the bit pattern for negative 12. Okay, because Python will magically pretend that all of the bits to the left are set. All right, that's how 2's complement works. What happens if we're doing 32-bit math, let's say, and we have 2 really large numbers, and we add them together and get a number larger than 32 bits can store? Well, at the CPU level, there's going to be something called an overflow. An overflow indicates that the number that the result of the math operation is too large. What Python will do is it will use more bits as needed. Okay, so typically instead of using just a single 32-bit to represent the number, it's going to use 2 32-bit numbers to represent the number. And so Python will do this automatically and elegantly so you never notice. Used to be that you can take a number and append to that lowercase l or uppercase L to indicate it was a long. That means it uses more than one of the 32-bit or 64 bits, whatever your system uses. But nowadays, that you can put that on there, but it means nothing. It doesn't do anything because Python will automatically convert between longs and regular integers. Okay. Note that no matter which format you use to represent the literal, they're all going to be integers. So for instance, 255, which is decimal, is the same as 0B11111111. It's the same as 00377, and it's the same as 0xFF. Okay, all of these numbers result in the same object, the same integer, 255. Okay, let's do some binary math. What are the math operations that you can do? We call these bitwise operations because they operate on the bits. The first is invert. And because of 2's complement, the effectiveness of this is basically when you invert some value, that's going to give you minus that value plus 1. And if you don't know why, you can play with the algebra of what it means to do 2's complement. Okay? Python will magically fill in ones as long as you need them when you're doing like AND operations. Okay? So we have the AND operator. Okay? This is bitwise AND. AND is one of those basic primitives in Boolean and binary math. The thing of AND is it's basically like multiplication. So 0 and 0 will give you 0. 0, and I hate drawing the ampersand. 1 is 0. 1 and 0 is equal to 0. 1 and 1 is equal to 1. So this is like multiplication. Okay, it's similar. All right. Then you have or a pipe B, which is bitwise OR. And what OR means is if any of the bits are set, then it's going to be true. So 0 or 1 is 1, 1 or 0 is 1, and 1 or 1 is equal to 1 as well. And then finally we have the caret, A caret B, which means bitwise XOR. XOR stands for exclusive OR, and it's only true if only one of the bits is set. So 0 XOR 0 is 0, 1 XOR 0 is 1, 0 XOR 1 is also 1, but 1 XOR 1 is 0. And these bitwise operations are performed over the entire range. Let me give an example here. So we're going to have 0B, 0110, 0110. And we're going to AND that with 0B, 1110, 1000. Okay, so let's go through the list here. 0 and 0 is 0. 1 and 0 is 0. 1 and 0 is 0. 0 and 1 is 0. 0 and 0 is 0, but 1 and 1 is true. 1 and 1 is 1. 0 and 1 is 0. So that is what you'll get when you AND those two numbers together. Let's do OR. So we have 0B, 0, 0, 0, 1, 1, 0, 0, 1, 1, 0, and we're ORing that with 0B, 1, 1, 1, 0, 1, 0, 0, 0. What that gives you is, let's go from the left this time. Well, that one's true because one of them's true. Both of them are true. Both of them are true. None of them are true, so it's 0. One of them is true. One of them is true. One of them is true, and none of them are true. So 1, 1, 0, 1, 1, 0. And XOR, so let's do that. And 0B, 1, 1, 1, 0, 1, 0, 0, 0, XOR. Okay. Let's go left to right. So we get 0B. Well, only one bit is set, so it's true. Both are set, so it's 0. Both are set, so it's 0. Both are 0, so it's 0. Only one is set, only one is set, only one is set, and none are set. Okay, so 1, 0, 0 is 1, 1, 1, 0. You can try this out from the Python command line. In order to see the bitwise representation of a number, I recommend using the function bin. So you put bin and you put the integer in there, and it'll print out a string that'll show you the binary representation of that. You can also do oct and hex if you want to gain more familiarity with those formats. Okay, there's two more operations. One is called A left shift B, and what this does is it's basically like multiplying by 2 to the power of B because it's moving the bits left. So for instance, you have 0B 0 1 0 0 and you shift left by 1, you're going to get 0B 1 0 0 0. Okay, and then you have right shift, which is like dividing floor division, 2 to the power of B. So 0B 0 1 0 0, right shift to 1 would be 0B 0 0 1 0. And if there's anything on the right, it's just dropped off. Okay, what are these used for? Well, to be honest, we don't really use these very much in Python. The only time we do bitwise operations is when we're interfacing with a program like C that tends to use bitwise operations to do its math, or when we're writing a protocol that has to encode things into bits and bytes in order to send it over the wire or store it to disk. There is also some interesting algorithms out there that use bitwise operations, like Bitwise Xor is typically used in encoding and encryption. The net effect of Bitwise Xor is it's finding the difference. It's like you're doing, it's pretty cool because it doesn't really destroy the data. It's pretty amazing. You can recover it later if you like do double XOR or something like that. It'll give you back the original data. The write shift is typically used if you want to process the rightmost bit, right? So you want to produce something with the rightmost bit, and then the next one, and the next one, and the next one. You want to keep like burning down that integer until you've gone through all the bits. Leftwise is a quick way to do multiplication. Or if you want to set like let's say you want to set the 7th bit. So what you will do is you go 1, left shift, and so the 7th bit I think would be 7, right? And so this should give you 0B01000000, right? So it's going to start with 1 and shift it left 7. 1, 2, 3, 4. Well, 1, 2, 3, 4, 5. No, this would be 6. You have to do 6. Okay, so you do 1, left shift 6. Yeah, I don't do this very often. And is typically used for masking. And what masking means is you're only interested in a few bits. And so you'll take the number, whatever that is, and you'll AND that with whatever filter you want. So this is saying I only want those 2 middle bits. And so whether those are set or not, we'll go through, everything else will be 0. Or is typically used to set bits, right? So if you want to set, like you have a number, whatever that is, and you OR that with like, let's say 0, 1, 0, 0, and the net result is that that bit will be set and the others will remain the same, okay? So that's typically what they're used for. There isn't much else to cover on this topic. These are some interesting operations to play with. I'm mostly exposing this to you just to get you used to Python syntax. This isn't really much that's going to be very useful in the future, but you do need to know about it. There's a lot of interview questions you'll be asked that involve these things. So this is something good to start early, to memorize, to play with, and to get familiar with. Anyway, guys, next video is going to be on how to do floating point math. So go ahead and take your time with the interpreter. Your homework assignment is to play around with all of these different operations. See if you can find any use for these things. And if you want, maybe you can go read some Wikipedia articles on these different things, and they'll give you some more examples on what these are used for and how they're used. Guys, I hope you have a great day. Take care, and bye-bye. This video is part of a series on the theory of Python. You can click on the left to see the playlist, and on the right to support my channel. Thank you very much for your time.